studying dust in galaxies. The galaxy at the back can act as a torch for the galaxy at the front, lighting up the dust inside it, which is usually obscured by all those stars. Now, if you look at X-ray images of galaxies on the Chandra website, for example, they tend to look totally different. Likewise, dust is doing a different thing from everything else. It's often in great clumps which are going to collapse and trigger more star formation. Now, NGC 3314's real name is Bill Keel. And by asking people to collect overlapping galaxies, he got us our first telescope time. He and Chris Lintott went to Kitt Peak in Arizona, and these are 3 of the overlaps they studied. So that was Galaxy Zoo's first success. Only very few overlapping galaxies had been known before, but between us, we collected about 600. Is it 600, or am I thinking of something else? Anyway, it's several hundred. Our most famous discovery came out of one of the questions that people ask on the forum. The most common question people ask on the forum is, what's this? And one of our forum members, Honey, arrived and said, what's this? And she'd spotted something very strange underneath a spiral galaxy. I'm not going to go into it in detail because I understand you've already had a lecture on it, but the science is incredibly cool. What we reckon is that there used to be a quasar in the centre of that galaxy. There's still the black hole, of course, but perhaps it's been obscured by dust and gas. Or perhaps there's simply no other matter for it to carry on shining. And in any case, it seems to have lit up this cloud of gas. Because it's so hot, and yet it contains no stars. It's the first object of its kind ever found. That galaxy is already known, it already has a name. It simply took a member of the public to come along and say, what on earth is this? That's where having millions of amateurs really helps things along, because there's just too much data to be getting on with. Well, there's so many other different things that people are asking about on the forum that I won't have time to go into all of them. A little bit later, Rick is going to give you a lecture about a kind of galaxy that we've named Ps. Little green round blobs. They seem to be quasars, and I'll let Rick tell you the rest. We thought that ring galaxies were incredibly rare. That was just always assumed as part of astronomy. It turns out we've found hundreds and hundreds of them. And in fact, it seems that 3% of all galaxies are rings, which is very strange because it takes a particular kind of merger to form a ring. What we reckon is that it's a spiral galaxy, a flat disk, and something comes directly head onto it, not at an angle, but imagine you have a plate here, absolutely vertical, something smaller, and that makes the core contract. The most interesting thing we found didn't really appear on the forum, but through our classifications. A computer can do most things for you. It can tell you the spectrum, it can tell you the distance, you can probably work out the mass, and it can tell you the colour of the galaxy. But it can't tell you the shape. And the shape indicates what the galaxy is doing. But people often wrote to us to say, have you noticed that spiral galaxies are blue and ellipticals are red? And we said yes, because that's a well-known fact. Well, Kevin was studying blue ellipticals, and it turned out there were red spirals as well. They took our classifications of spiral, and hey, the computer's saying these are red. The reason that spiral galaxies are usually blue is because they're usually star-forming. There's plenty of free gas left in them. Whenever there's blue in SDSS colours, that indicates star formation. These arms are density waves, rather like traffic jams on the motorway, and eventually you're going to get through that traffic jam and go away again. But in a spiral arm, there's a lot of disruption happening that's going to make the gas clouds collapse, and you're going to have new stars. In an elliptical, on the other hand, the stars are all going their own way, really. They're not in an organised disk, they're not making any traffic jams, and also there isn't any free gas left available for star formation. But interestingly, spirals tend to live alone, and ellipticals tend to live in great big clusters. Well, the paradox that Kevin was studying is the blue elliptical. They're star forming, but they shouldn't have any gas there, there shouldn't be any triggering of collapsing of gas clouds by density waves. So we're not quite sure how this is happening. Well, something else that we noticed is that blue ellipticals tend to be alone, like spirals. That provided a clue. Red galaxies, on the other hand, red spirals. Again, there tended to be no star formation going on. There were still the density waves, but that didn't really trigger very much. And they tended to be in clusters. So this is what we think is happening. And rather like the Bohr was a discovery of a new animal, this is a discovery about the whole ecosystem. We reckon, imagine a spiral on its own, orbiting round and looking beautiful blue, but it's gradually heading towards a cluster under the influence of gravity. In a cluster, about half the mass is in stars and the rest is gas, free gas, not done anything yet. And I'm not even counting the dark matter there. In a cluster of ellipticals, it seems that the galaxies all affect each other. It could be that they blow away the gas from the others, it could be that they've already absorbed it all. But in any case, they seem to strangulate each other, as it's called. If you're with another bunch of galaxies, then your star formation gets shut down. So that's what happens to this poor little spiral as it enters the cluster. And it could be that as it gets further into the cluster, it's probably going to merge with one of the galaxies there. And we reckon that elliptical galaxies are probably so disorganised because they're the end result of mergers. And that puts ellipticals exactly where we want them to be. So that puts an end to the all spirals are blue and all ellipticals are red scenario that has been assumed for a long time. And it was masses of data that let us find that out as well. Well, we're moving on a bit now. We've done all the classifications, much to the zookeepers', I won't say horror, I'll say shock, because they weren't really ready for that to happen so quickly, so they've been rushing to get ahead with Galaxy Zoo 2. But this time they're going to ask for some different classifications, much more detailed. A question we often get asked is, why don't you classify according to Hubble's tuning fork? With ellipticals at one end and spirals at the other, because a lot of people who came to classify did know about it, although many more didn't. And we said, well, for one thing, we don't want to put people off by being too scary, but for another thing, the tuning fork wasn't really the point. We simply wanted to know if it was spiral or elliptical. Anyway, we're going to be using the tuning fork now, not by making people learn it, but simply by asking, does this have a bar? If it's an elliptical, is it very long, cigar-shaped, or is it round? So by the questions people are going to get asked, the galaxy is going to get placed on the tuning fork. We don't know what we'll find this time. We're not asking specific questions anymore. But we're pretty sure we're going to find something. We found the unexpected already. And here's an example of some of the questions people are going to get asked now. So for example, if it's an edge-on spiral, there's often a bit in the middle, the bulge, and the yolks of the two fried eggs, as they call our galaxy. But what shape is it? Apparently some are square.